Hello everyone and welcome to the Math Bender. In this section we'll discuss further more on right angle triangles and more tools related to them. Okay, so first thing, if you see a right angle triangle, so let's say this is the 90-degree angle. We already established that this is the hypotenuse, the side that is the longest side. Now I'll call this triangle ABC. This is how I'll represent triangle ABC. Now trig ratios are the ratios of length, and so sine, cos and tan, these are the three trigonometric ratios mainly, and they represent the ratios of a length in a triangle. So if I say sine of angle A, sine represents the opposite side over the hypotenuse, cos represents the length of the adjacent sides over the hypotenuse, and tan represents the length of the opposite side over adjacent. We remember it like this. So, ka toa, which means sine of an angle. Remember that sine has to be with an angle. It is not possible, it cannot be with an angle. So sine is opposite over hypotenuse, cos of an angle is adjacent over hypotenuse, and tan of an angle is opposite over adjacent. So let's see if we have in this triangle, according to A, if I say this is small a, and let's call this small c. So when I'll say that what is sine of A, then according to the angle A, the opposite side is small a over the hypotenuse stays universal, which is h. If I say cos of angle A, then since cos is adjacent over hypotenuse, so adjacent side to angle A is this one, which is C over hypotenuse, and tan of angle A is opposite to angle A, which is A, small a, over adjacent, which is C. Same case, if I write with respect to angle B, so sine of angle B is equals to the angle B is not it does not apply on 90 degrees. Sine of angle C, I'm talking about this one. So according to C, the opposite is not anymore A, the opposite is going to be now C, small c, over hypotenuse is H. Now cos of angle C is adjacent over hypotenuse, and now adjacent is A, the side that is with angle C, over hypotenuse, and tan of angle C is opposite over adjacent, which in this case is C over A. So remember that the sides that we name opposite or adjacent actually switches with respect to the angle. When we say opposite, we mean that that is opposite to some angle, and what angle is it, that you will decide, whichever, or the question will ask. Let's move on to some questions related to it. So let's say if you have a triangle, the first step that you need to do is identify the hypotenuse, and hypotenuse is the side. which is opposite to the 90-degree angle. So the question one part one says that sine of angle A. So sine of angle A. So since sine is opposite over hypotenuse, so let's talk about this angle. The opposite side is this, we can say opposite with respect to A, and this is adjacent, which is with respect to A. So opposite over hypotenuse. So sine of angle A, opposite is 24 meters over hypotenuse, which is 25 meters. Same way, cos of A is adjacent over hypotenuse, which is 7 over 25, and tan of A is opposite over adjacent, so opposite is 24 over A is 7. So this is how you find their values. But when it comes to angle B, now this is the opposite side and this is adjacent. Hypotenuse remains the same. So if I have to find out, let's say, sine of angle B, then sine is opposite over hypotenuse. So opposite is 7 over hypotenuse is 25. Cos of angle B is adjacent over 25 and tan of angle B is opposite over adjacent. So this is how we find. Let's take a look at some of the questions we have. So in this you have a right angle triangle, and as you could see, first right angle triangle is the big one, which is making a right angle at angle A. And then the next right angle triangle is this one. And the third right angle triangle is this one. So there are three right angle triangles, so trig ratios can be applied there. You need to remember that Pythagoras theorem is also a technique to find one of the side when two sides are given. But trig ratios are only applied on any triangle, on any right angle triangle, when either an angle and a side is given and they're asking you to find out the second side or otherwise. So let's say it says that AH is perpendicular, so which means making a 90 degree to BC, so you have to find AH. So I need to find out the length of AH, and let's erase it for a moment and check this triangle. Now this triangle has right angle triangle. Since we only know about right angle triangles so far, so we look at them with only this perspective. So in this we have nothing given. We don't have the length of this side or this is what we have to find. Neither the angles are there. It's this making out or highlighting this triangle won't be of any use. So let's try to identify any other triangle which I could get help from. So if I see this triangle, this is also a right angle triangle in which angle is given, one angle is given, and there is a side given, and this is a 90 degree angle. It's a supplementary. So this is the hypotenuse because opposite to the, and then according to the angle, according to the angle 56, this is the opposite and this is the adjacent. So I write from triangle ABH. This is the statement which means that I am using triangle ABH to identify or to find my question. So from triangle ABH, I need to find out opposite, and I have hypotenuse. So remember these tools that we identified, So O and H are used. So O I have to find out and H is already given. So which means this is the best way I can find out, because neither of them will cater to more uh, my solutions. So I'll write sine of 56 is opposite, which is AH. In this case, you can also write opposite or X or anything, over hypotenuse, which is 8.9. And 8.9 times with sine 56 is equals to AH. Now, let's look at this. 8.9 times sine 56 is 7.4. So AH is equals to 7.4 meters. Now, if I have to find out HC for part C, part B, I have to find out HC. So I can write that the length that I've just found out is 7.4 and it is here. Now, if I'll try to look at other triangles, so I have to find out the length, this length. This length HC, and this length is a part of a triangle AHC, which I don't have much help again, but if you look at it, then this big triangle, here, A, B, and C, from the triangle ABC, I have a 90-degree angle, I have a 56-degree angle, and I can easily find this angle too. So I'll write my statement from triangle ABC, 90 plus 56 plus angle C is equals to 180 degrees, since we know that the sum of all the angles in a triangle is 180 degrees. And if I subtract both the angles from, so I get angle C as 34 degrees. So this triangle here is 34. Now looking at the same triangle which we highlighted before, this one, and I have to find out HC. And here, now this is the hypotenuse, this here is the, let's find it out. So I need to find out this side HC, and I have AH, and I have an angle as well. So according to the angle, this here is the opposite and this here is the adjacent. I do not need hypotenuse to use, so I have to apply a ratio from these three in order to find the adjacent, and I have the opposite. So can you see that the angle will be catered by tan, opposite I have, and adjacent I have to find. So I'll use tan of the angle 34 is opposite, which is 7.4, over adjacent is HC. You can also use X, or you may name it whatever you like. So HC times tan 34 is equals to 7.4. HC is equals to 7.4 over tan 34. We write this as 7.4 over tan 34, which gives you 10.97 meters. So the three ratios, what you could think of is that when you have a right angle triangle, you have one angle given and length of one side, and you are to find out the other sides, you may use these three ratios. Let's look at this one. Here I have to find out angle A, and in this triangle I have this as the opposite, and according to the angle A, this side as the hypotenuse, my apologies. Uh, Angle, according to the angle A, the opposite side is here, and according to the angle A, this is the adjacent. Because I am talking with respect to angle A, the reason being that I am only concerned about it, that's what I have to find. So I have opposite given as 12, hypotenuse given as 26, and I have an angle that I have to find. So O and H. So let's go back and check. O and H is used in this. So sine. Alright, so moving forward with another question and a complex example. So in this situation, you have three triangles. Two of them are right angle triangles. So triangle PQR is a right angle triangle, the big triangle that you see. In triangle, so let me construct it easily so that we can have a clear idea what are the values. So PQR, where this is 7.6, this is 17.4, and this is the 90-degree angle. The other right angle triangle that I can construct is triangle PKR. So this here is PRK, this is 7.6, and what we need to find out is QPK. So the plan is that if I am able to find out this small angle and I subtract from the big triangle's angle, then I'll be able to find this small portion. So let's try to see. So from triangle PQR, I can find out, I need to find out this angle, and what I'll use is, according to this angle, I have adjacent, and according to this angle, this is the hypotenuse. That's the first thing that you need to mark. So adjacent and hypotenuse are used in cosine. So cos of angle P is equals to 7.6 over 17.4. And P, since you have to find the angle, you have to take cos inverse 7.6 over 17.4. So now taking cos inverse 7.6 over 17.4, which gives you 64.1. So P is equals to 64.1 degrees. So you can write that. So you can write that down as, so the big angle here is 64.1. So let's say if I have to mark with a different ink, then let's erase all the other ones. So the green one is 64.1. I'll have to find out now the small one here. Now, as I can see that this angle here is supplement to 137, and I can use 180 minus 137 to find out this angle. So this is 43. And I have to find out this small angle. So it's automatically, as I can see that, from triangle PKR, I can say 43 degrees plus 90 degrees plus angle small p, I'm just naming it as small p, is equals to 180 degrees. And if I subtract both of the angles from 180, this is going to be 47 degrees. So this angle here is 47 degrees. Now, as angle is just the opening, and as you could see that the big angle, the green one, is 64.1, the small one is 47 degrees. This small portion is going to be hence 64.1 minus 47 degrees, which you can write as 17.1 degrees. Now, the length of QK, you have to find out the length of QK, this one. Now, technically, it's a part of a triangle PQK, which is not a right angle triangle. And since we don't know the tools to solve any ordinary triangle right now, we cannot approach it as well. So, what we can do is in the triangle PQR, if I'm able to find QR, the big side, and if I'm able to find KR, the small side here, this one, and I subtract both of them, I'll be able to find QK. Let's approach it. So for part B, from triangle PQR, I have two sides given, 1 and 2, and I have to find the third side. So rather than applying any trig ratio, I can straight away apply Pythagorean theorem. So 17.4 whole squared is equals to 7.6 whole squared plus QR squared, and 17.4 whole squared minus 7.6 squared is equals to QR squared. You can write this as 17.4 squared minus 7.6 squared, and if you root it, it's going to be QR is equals to 15.7. Now let's try to find out the triangle. We already know that this here is 43. We do not have other two sides. So hence we cannot apply the Pythagorean theorem. So in this scenario, we'll apply trig ratios. So trig ratio, this is opposite and I have to find the adjacent. So I'll write tan 43 is opposite, which is 7.6 over KR, and KR times tan 43 is equals to 7.6. So KR is equals to 7.6 over tan 43, and you use a calculator. 8.2. Now look at this. This here is 8.2 and the big one is 15.7. This big one is 15.7. So if you subtract both of them, 15.7 minus 8.2, you get QK. $7.5. This is what QK is. I hope I've made myself clear in this. Until next time, take care. Bye.